Hello guys, that Juan guy here, and today we're going to be starting episode 2 of our C programming tutorial. What this tutorial will cover is how to prepare Linux for C development. So first, you gotta install a set of tools on Linux so that you can compile, and there's a few other things included in this command right here. Yum and group install development tools, or apt-get install build essential, which are OS specific. So basically what you're going to do is run these two commands. So yum update -y for CentOS, or apt-get update -y for Debian or Ubuntu. This basically just it updates the system packages, and it updates the index of repositories where all the packages are, so your computer knows if that package exists, where that package is, and the version and stuff. And group install development tools, again for CentOS. It will install GCC, Make, CMake, G++, just very many tools you'll need if you're developing programs generally for C. And or you could run apt-get install build essential for Ubuntu or Debian. And now once you have that installed, you want to run gcc -v, and this will show you everything about your GCC. What you want to look at, it's basically version. Well, not really, but if it's not installed, say you did, it would say command not found. If you did GCC and it said command not found, you may have some serious problems. Like, I don't know. Probably have a distribution that doesn't use yum or apt as a package manager, and you might want to figure out how to go about installing GCC for your distribution of Linux. Pick a text editor. So there's Vim, which is, oops. Okay, so Vim is usually built into Linux. It's like the default text editor. But in case you don't have it installed, here the install commands for CentOS and Ubuntu and Debian. Or you can use Nano. I prefer Nano. This is what Nano looks like. It's got a great interface. I find that Vim, it's just not as appealing. You gotta press I to type text, you gotta press escape to get out of that, and then to exit, you gotta know special commands like WQ means right quit, which I didn't give it a file name, but you see how much of a struggle that was when I could just Control O, write it, and then Control X cancel, in Nano, but I guess it's user preference. So get out of Vim. What you're gonna want to do is you're gonna want to have your file, of course. Touch is a command that basically creates a file. Yeah. There's something funny here. You can touch penises in Linux, but no one wants that. Anyways, so if you type vim test.txt, which is your file name, you'll see opens the window. You can't type text. It just, I spam it and it starts working, but I think I'm pressing I. Anyways, so you're going to want to type some text. Let's just say that one guy Vim tutorial. XD, what are those? Alright. So you press I to go into insert mode, and you can insert text now. escape will take you out of it, and you could see it here at the bottom. Like if I press I, it says insert. That's how you know you're in insert mode. If you want to find a word, alright, you're going to want to escape the insert mode. You're going to want to be in the view mode, and you're going to type / XD, and it'll highlight it for you. And, you know, yeah. Or what are those? And now you can press enter, then N, and it'll take you to the next occurrence of it. And I mean, that's basically all you'll really need to know about this text editor. Now we go to Nano. So let's make a second file here, and then go to test2.txt, which nano space and the file name, which is test2.txt. This interface, it's more graphical to me. You know, there's all these commands down here. It's not as much as Vim, but like, it's more understandable. So we can write some text. We can write nigger. We can write that one guy. And let's just put a couple pages here. Alright, so what I did is Control O, Control X, which -O writes, and then Control X quits. And Control W, you know, it even tells you you're searching when you press Control W. That's how you know it's like, you know, kind of a better option. Although you can't just press enter, you gotta spam Control O. But, you know, it goes through them. It's very useful. Control V is for page down. I don't know why in the notes I have this page up. I'm fucking stupid. But Control Y goes back up. That's it for... yeah, that's it for the, text editing. So, you'll need access to a Linux OS / Vision. You'll need Vision to see what I'm typing on the screen. Less than half a brain and the will of a fucking tiger, okay? Don't forget that. If you don't have the will of a tiger, please leave now. I'm not responsible for you not being able to code because you don't have the will of a tiger. But, so there's color codes. Shit. Yeah, let's move this slide up here. So, instead of going over the color codes first, we're going to go over the first program, which is a very simple program. We're going to name it hello world.c. And if we compile this, there's no reference to main. So you're going to need a main function for the program to compile, which if you want to get really advanced, you can specify which function it is. It doesn't have to be main, but you have to, you know, implicitly specify which function it is. Which this series will cover some of the compiling flags later in other episodes. But there's nothing in it yet. Let's go ahead and write some code. Include Stdio.H, which is standard input / output. It's a library, which a library is a collection of functions that are not necessarily built into C, because you can make your own libraries, but you know, there's some built-in ones that are practically impossible to live without, like Stdio. You know, it offers, you know, the printf function, the scanf function, There's a bunch of others. So what you're going to want to do is you're going to want to have int main. Int argc, comma char argv. Let's just change this because I'm about to explain what all this means right here. So int, it's a data type, right? And all functions have to have a data type, alright? So this whole thing right here is a function. Int is, it stands for integer, which is any whole number, which means it can't have a decimal point. You know, if you remember basic math class, and you know, it's a whole number, 1 through like 2 million or something, or negative 2 million through 2 million. Is what int actually means on a 32-bit system, which a 64-bit system just has double the size of an integer. Excuse me. Main right here is the function name. It can be any name, but there has to always be a main function. Inside the parentheses, you specify the arguments or the parameters, whatever you want to call them, for the function. For main, you specifically have to have 2 or 3 arguments, which you don't really need the third argument. There's very rare cases where you will ever need it. It's I forgot what it is because I don't think I've ever used it, honestly. It's like the environment or something. Not really sure what it does. But int argc is an integer for the number of arguments, so it's arg count. Char, a character is, it's a number that represents a character on the Ascii standard, which the Ascii standard is a collection of special characters, anything on your keyboard basically that can be represented by a number that the C compiler can read, can understand. And just this alone in a variable name would be one character, but since we have a pointer to operator, it becomes a string of characters, meaning there's more than one. And so this is an array of that because it has, you know, the array operators, which means there's multiple strings. So like, you know, there's one compilation of characters, you know, that's your first argument, and there's a second one. So what you can also do here is make it a double pointer. They basically do the same thing, although there's some cases where the C compiler reads them different, but in this case it don't matter. So what exactly an argument or parameter is when you go to run your program, you do ./hello world or whatever you compiled the program to, and this would be arg1, arg2, and so on. Just, you know, you can have like an infinite number of these things. Although that would be crappy and you'd have to type it in every time. You know, not good practice there. So printf prints the std out, which there's 3 main standards for your terminal. There's stdin, which is your user input into the program. There's stdout, which prints text on screen that is not an error, and there's stderr, which is for printing out specific errors, which I don't know why they don't just put it in stdout. It's kind of redundant. So printf, you need quotation marks and always a semicolon at the end of a function definition or initializer. or the calling of a function. Inside it, you can put anything, alright? So, you know, you can put, I am a new C coder and my name is %s, which is a format specifier meant for passing in a variable, which we can create a variable right here in our underscore name equals, you know, Bob. Our name's Bob. And let's put a comma to give it, the function, a second argument, which would be our name. Which printf is a variadic function. You can pass as many variables to it as you want, as long as there's an adequate amount of specifiers for how many ever arguments you give it. Which %s is to define that it's a string you're passing in. Turn 0 means success, and so this -r-n is special. It actually prints out a new line and moves your cursor back to the starting position. /r whoa. /r resets the cursor back to the beginning, so if our cursor was, say, right here, it would go all the way back to right here. And the new line would then proceed to move it down. So now we have our program. I kind of went in a little bit in depth, just giving you an idea of like all the terminology you'll be hearing and like, you know, just general basis for how the C program works and, you know, what's in it. And now we can compile it. Okay, so first you're going to want to type gcc -o. This flag, which -o is a flag, specifies where you want to output the file. And you can put a space. You don't have to necessarily, but if you put a space, you know, it's the same thing. And then you want to type the file name or file names, which we'll cover more in this series. So stay tuned, guys. Oh, look, like, go back here and take this out. You know, it's still the same thing. It saved it as the same file. But to run it, you want to do // which is a \/. It's what it's called. And it indicates that you are trying to access a file in the current directory. Hello world. I'm a new C coder and my name is Bob, is what it should display with a new line, and you know, looks nice and clean. However, oh, I'm such a bad typer. So I mentioned these earlier. I said they were to reset the line and make a new one. So let's try it without either of them. We compile it. Oh, something doesn't look right about that, right? Nano hello world.c. As you can see, it didn't reset it and it didn't make the new line. But let's try just a reset, which should corrupt the data, and it says E is Bob. So now we can try just the /n, which it might automatically print the reset character, which it does. But still use the /r. It's common practice. It's you know. Anyways, so there's ASCII color codes, which involves an escape character. There's several of them. There's a bunch of different ones you can use. I mean, they don't really change how the program works or anything. There's just different ways of escaping to call in some sort of command, which color codes use an opening bracket, a number, M. This is only 8-bit color coding, but it goes up to 255-bit color coding. So let's take a look at this. So if we wanted to give, say, Bob a color, we would do /033 32M. This will make a green color, I believe. And next, what we're going to want to do sounds a little overkill, but to make sure the next line isn't colored, we're going to want to reset it with a 0M. You know, type out the same escape code and type 0M. And when we run this, it says my name is Bob, and Bob is in green. There's a bunch of different color codes here, and I will leave a link to every possible color code in the description. And here are the different escape codes. I mean, that's pretty much it. I guess I'm going to show you, the usage of the different escape codes. So we already used /033. Let's try /E and see if that works. Yep, same result. And let's try /x1b. /x1b. There will also be a link to my GitHub in the description, which will contain every future, and including this one, every future, source code for all the files and everything. Look, I have it saved in folders, which I'll be uploading along with the list of commands and stuff to GitHub in case you wanted to, take a closer look at this, get some practice in, all that good juicy stuff. Anyways, that is it. That one guy out. Peace.